Hello learners. In today's lesson, we're going to be looking at functions, and we are specifically dwelling deep into the hyperbola functions. So I'll be telling you all about hyperbola functions, and we'll be investigating all the effects of the hyperbola function. I'll just be going in depth with explaining how you answer those hyperbola functions question. So without any further ado, let's just get right down to the lesson. But then do not forget to like and subscribe to the channel so that you get more of this content. So now we are given the hyperbola graph, and then that's the formula. We have y is equals to a over x minus p plus q, right? And then we know that all the hyperbola graphs are there to that formula, whereby now we know that the a determines the wideness of the graph and the positions of the graph in the quadrants. So now you will notice that we have here the first quadrant, and then the second quadrant. We have the third quadrant there, and then we have the fourth quadrant. So now what is it that we know? We know that if our A is positive, our graphs occupy the first and the third quadrant. So the graph is positive on the first and the third quadrant. But what happens if our A is negative? That means our graph is negative in the second and the fourth quadrant. So there you have it like that. Then here our P determines the vertical asymptote. So this will be the asymptote that will be going vertically up, which will be represented by the equation of x is equals to that particular vertical asymptote. And then Q is the horizontal asymptote, which will be going horizontally from left to right. Then it will be represented by y is equals to that particular horizontal asymptote. So now let's check what is going on. Let's get into the questions. So now we have the effects of A. Let's look at the effects of A. So now we want to see if really A determines the wideness and the position of the graph, right? Then we can see that our A here is positive, so we expect our graph to be in the first and the third quadrant. As we can see there, it occupies the first and the third quadrant. But what happens as our A is that small? A is equals to positive 2. So what do you notice with the wideness of the graph? We can tell that the graph is not that wide because it is closer to the axis. As you can see here, the graph is close to the axis, close to the x-axis, close to the y-axis, right? So we can tell from this that the graph is not that wide. Now let's check. Let's say now we increase the value of A. Say let's take it to 5, right? Now when we take the value of A to 5, what do you notice with the graph? You can see the graph is starting to become wider, right? So you can see that it is becoming farther away from the axis, right? So it's becoming farther away from the y-axis and farther away from the x-axis. So that's how we see that the graph is becoming wider. So now when we increase A, we expect the graph to become wide. We still have our graph occupying the first and the third quadrant like that, right? Then let's proceed. Let's say now we increase the value of A further. Let's take it to positive 15. So when we take it to positive 15, you can see now, you can clearly see the effects of A. It is becoming wider now. It is becoming wider and becoming farther away from the axis, right? So we say now, what can we conclude? We say the effect of A on the graph is that it increases the wideness of the graph. So still our A is positive. It's in the first and the third quadrant. Now let's look at what happens when our A is now negative, right? So our A is negative. Let's start with negative 3. We can see again that the graph has become a little less wider, right? So here it occupies the second quadrant and the fourth quadrant. Why? Because when A is negative, we have our graph in the second and the fourth quadrant. But what is happening to the wideness? The wideness is not that much, because remember now, the value is now a -3, right? So it is the size, we can say the size is now smaller, right? That's -3. But then what happens when we start to increase that magnitude, that size, in the negative direction? In this case, we are now decreasing the value of A. So this is what happens. If we move from -3 and then we go to -6, what happens to the wideness of the graph? The wideness of the graph increases, right? So you can see now when it's -6, the graph is becoming farther away from the axis, right? You can see here that the graph is now farther away from the axis. So what are we doing to the value of A? We are now decreasing the value of A, right? So from -3 to -6, that's a decrease in the value, right? But then remember, if we have to think it in this way, it's more like we are increasing it in the negative direction, because what is happening to the numbers? They increase, but then in the negative direction, right? So hence the graph is becoming wider and wider, right? Now let's check if we go to -18. So -18 is a bigger number, and then in the negative direction, right? So what happens to the wideness of the graph? The graph starts to become wide, right? So it is becoming farther away from the axis, right? So you can see that the graph is wide like that. So now we have seen the effects of A. We have seen the effect of A. Negative, it still occupies the second quadrant and the fourth quadrant. So we have seen the effect of A is that it determines the wideness of the graph, and it also tells you in what quadrants will your graph be, right? So when A is positive, it will be in the first and third quadrant, but when A is negative, it will be in the second and the fourth quadrant, right? Now let's look at the effect of P, which is the vertical asymptote, right? So we have our equation there. It's y is equals to -3 over x minus 2. So from this one, you can tell that we have the vertical asymptote there. But then what is our horizontal asymptote? For interest's sake, we can see that we don't have anything here. We don't have plus q. But then if you don't see anything there, that means your q is 0. So your horizontal asymptote is 0. As you can see with the graph, when you look at the graph, you can see that it is not touching the x-axis, which is that 0 line. So the equation of the x-axis, remember, is y is equal to 0, which is your horizontal asymptote. But then how do you get the vertical asymptote? This is how you calculate the vertical asymptote. You simply take the denominator there and equate it to 0, right? So you have that denominator x minus 2, equate it to 0. Now you'll have x is equals to 2. That becomes the equation of the vertical asymptote, right? So you can see that when it is a negative here, then your vertical asymptote is a positive. But once you have a positive there, your vertical asymptote will be a negative, because first you need to equate it to 0 and then transpose it, right? So now we can see the P there, right? Where is it? Where do we draw it? We draw it on 2, right? Because remember, we calculated it to be x is equals to 2. So after drawing that vertical asymptote, you need to come here and indicate the equation of the asymptote and say x is equals to 2. So yep. Let's check another one. Let's say now we have y is equals to -4 over x plus 3. As you can see, our a is negative, so it's in the second and fourth quadrant. So now your quadrants, remember, now your vertical asymptote now determines the quadrants. This is now your first quadrant. This is now your first quadrant. second quadrant, third quadrant, and fourth quadrant, right? So let's check for the equation of the vertical asymptote. For the equation of the vertical asymptote, we need to again take the denominator and equate it to 0. So we have x plus 3 is equals to 0. Then we have x is equals to negative 3, right? So once again, we can see that if we have x plus 3, then our vertical asymptote is x is equals to negative 3. So where do we draw it? We draw it here on the negative x-axis, right? So we can see that it is crossing all the way like that. Then we indicate that x is equals to negative 3. So this is the vertical asymptote because it is going vertically. But remember, the vertical asymptote cuts the x-axis, right? So do not be confused. The equation will be x is equals to negative 3 because it cuts the x-axis, right? So that's your asymptote. Now, what is an asymptote? This is basically where the graph, where your graph will never touch, right? So you never have any value for that. For example, if you put negative 3 there, if you say negative 4 over negative 3 plus 3, then obviously here you'll have negative 4 over 0. Now we know every time we divide by 0, the answer is undefined. So we say the graph will not touch there. We will not have a value, right? So that's an asymptote. That's where we never have a value for that particular x coordinate or y coordinate. Now, let's check the effect of P, which is the horizontal asymptote. Now we have y is equal to 5 over x minus 3. So from this one, we can see that the horizontal asymptote is 0 because remember we have x only here, right? So you can see even with the graph will not touch the y-axis, right? Then we know that the equation for the y-axis is equals to x is equals to 0, right? So it will never touch there. That means the vertical asymptote in this one is x is equal to 0. So you never find it like that and say there is no vertical asymptote, right? There is always a vertical and horizontal asymptote in your hyperbola graph, right? So if you don't see it, then it's 0. Then for this one, for the horizontal asymptote, you just take it the way it is, right? So you can see y is equals to 5 over x minus 3. What is your horizontal asymptote? You just simply say y is equals to negative 3, right? So you simply take the q here, right? The q just becomes your horizontal asymptote with its sign. So if it's a positive, that's positive. If it's negative, it's negative, like that. So that becomes your horizontal asymptote. After drawing it, you need to label it here y is equals to negative 3. Then like that. Let's look at another one. This time we have y is equals to 3 over x plus 1. Once again, we can see that our vertical asymptote is equals to x is equal to 0 because you can see the denominator there only has x, right? So as you see, the graph does not touch the y-axis, right? That's the asymptote. But what is the horizontal asymptote? We can see that we are given positive 1. So immediately we just say the equation of the horizontal asymptote is equals to y is equals to 1, right? Y is equals to 1. So we can see that the graph there is cutting the y-axis, right? So it becomes y is equals to 1. You label it here, y is equals to 1. So it cuts the 1 here on the y-axis. Remember, horizontal asymptote cuts the y-axis, vertical asymptote cuts the x-axis, right? So do not be confused. Then let's check if now we have the horizontal asymptote and the vertical asymptote visible in the graph, right? So In this case, we have y is equals to 3 over x plus 1 minus 2, right? So if we're to determine the asymptote here, we'd say for the vertical asymptote, you take this denominator, x plus 1, and you equate it to 0, right? And then now you'll have your equation of the asymptote as x is equals to -1, right? So where is it? We expect it to cut the x-axis going vertically up, right? So this is it. The yellow one is your vertical asymptote. X is equals to -1. As you can see, it's cutting through that -1. But then what is your horizontal asymptote? Your horizontal asymptote, remember, is that Q there. So the constant that we see there, that's y is equals to -2. As we can see with our graph, it's cutting below the x-axis at -2, right? So here is it. We label y is equals to -2, right? So that's how you have it. That's how you have your graphs. Now, let's look at another one again. This one has -a, so we can see that it's in the second and the fourth quadrant, right? So now what is happening with this one? We can see that what is our vertical asymptote? We need to take that x minus 2 and then equate it to 0. Then we have x is equal to 2, right? As we can see, the yellow line there shows you your vertical asymptote. We label it here, show it clearly, x is equals to 2. But what is your horizontal asymptote? Remember, with the horizontal asymptote, you take it as it is. So that's -3. So we say y is equals to -3. Then we indicate it here. This is the red line. Y is equals to -3. That's your asymptote. So here we have the vertical and horizontal asymptote both visible in the graph, right? So awesome. Now let's look at the 5 key questions that they normally ask in hyperbola questions, right? Then this is number 1. They will ask you to write down the equations of the asymptote. So we can all attest, if you have seen a lot of previous question papers, you will see that that always comes out as the first question. They will say write down the equations of the asymptote, where you need to provide the equation of the vertical asymptote and the horizontal asymptote. Then number 2, they will ask you to calculate the intercepts of the graph, which is the x-intercept and the y-intercept. Then number 3, you will be asked to write down the domain or range of the graph. So they can either ask you to determine the domain, or they can either ask you to determine the range, or they can ask you both, right? Then 4, they say determine the equation of the line of symmetry with a positive gradient, or they can ask you to determine the one with a negative gradient. Then number 5, that's where you get to sketch the graph, showing clearly all the intercepts with the axis and the asymptotes, right? So these are the 5 key questions. Yes, you will get some other questions, but then just there and there, they might ask you about, they might ask you to get like one coordinate in the graph or whatsoever, but then these ones are the ones that are most likely to come out of your question. These are the ones that they always ask when it comes to hyperbola questions. So if you have mastered these 5 key questions, then I could say that you pretty much have a chance in answering hyperbola questions. Then 1, it says write down the equations of the asymptote. So remember this one, we have already done it. It's simple. So now for the vertical asymptote, we know we just take this one, equate it to 0, so that x minus 5 is equals to 0. Then we'll have x is equals to 5. So basically, when you write it in your exam, you just go x is equals to 5. There is no need to indicate that x minus 5 is equals to 0. So remember, they only want you to write down the equation, right? So you just go x is equals to 5. When it is a negative here, you know it will be a positive. When it is a positive, it will be a negative. Then for the horizontal asymptote, again, you just say y is equals to, you take it as it is, right? So we can see that's -2. So we say y is equals to -2. Now that way you have the vertical and the horizontal asymptote both for 1 mark, right? So that would be a 2-mark question. One for getting the vertical asymptote and one for finding your horizontal asymptote. Now, number 2, calculate the intercepts of the graph, right? So normally with this one is start with the easier one. The easier one is to calculate the y-intercept. Now you will remember y-intercept, that's where you make x 0, right? So this one is straightforward because you just go where you just put 0 where there's x, right? Then y is equals to 3 over 0 minus 5 minus 2, right? So solving that, you have y is equals to -3 over 5, right? So if you punch that in your calculator, it will give you the answer. But then since I don't have one, I'll try to solve it manually. So we have -10 over 5, and then y is equals to -13 over 5, right? So that should be your answer for that one. So -13 over 5, which should give you something like 2 point something. Then let's calculate. So this one is for the y-intercept where we make x 0. Then what about the x-intercept? So for the x-intercept, remember we have to make y 0. So for the x-intercept, you make y 0. So remember, what do we have in our equation? We have y is equals to 3 over x minus 5, and then we have, is it minus 2? Yes, minus 2, right? So now what you want to do is you want to put 0 where there is y, right? Substitute 0 where there is y because the x-intercept we make y 0. Then we have 3 over x minus 5 minus 2. Now at this point, in order to continue solving, you need to take this -2, transpose it to the other side. So you want to isolate the fraction, right? So we have 2 is equals to 3 over x minus 5. Then remember that 2, if you write that 2 in terms of fractions, if you write that 2 in terms of fraction, you have 2 over 1, right? So you can just make it a fraction. Then it's just a matter of cross multiplying. There you have 2x minus 5. And then you have 1 multiplied by 3, that's 3. Then you can just multiply inside with 2. You have 2x, and then 2 times -5, that's -10, equals to 3, right? Now at this point, you have 2x. You can transpose the 10 to the other side. So that becomes 3 plus 10, that's 13. And then if you divide both sides by 2, divide both sides by 2, that's x is equals to 13 over 2, right? So x is equals to 13 over 2, which if you punch it in your calculator, it gives you something like 6 point something, right? So that's, is it 6.5? Yes. Now they say write down the domain and range . Write down the domain and range of the graph, right? Write down the domain and range of the graph. Now, what is a domain? You will understand that when we say domain, we say this. A domain is a set of all possible x values, right? Domain is a set of all possible x values. So here, remember, all x values are valid, right? So we say x is an element of real numbers, right? So this is where we now get to x element of real numbers, but where x is not equals to 5, right? Where x is not equals to 5. How do we get that one? So the one that we restrict out from the domain is usually the asymptote, right? So remember, we are saying that on the asymptote we don't have a value. That's where we don't have that's where the graph does not touch, right? So formula to write the domain is just to say x element of real numbers and then exclude the asymptote, right? The vertical asymptote. So x is not equals to 5. Then for the range, also for the range, you do the same thing. You say y element of real numbers, but now you have to exclude the what? The horizontal asymptote. So you say for where y is not equals to -2. So that's how you come up with your domain in range. X element of real numbers, then you exclude the vertical asymptote. Then for the range, y element of real numbers, but you exclude the horizontal asymptote, right? Because remember, there are no values for those two, right? The graph does not touch there, so it does not produce any value there. So remember, domain set of all possible values, but x is equals to 5 is not a possible value since it's an asymptote, and then range is a set of all possible y values, but y is equals to -2 is not a possible value because the graph does not produce any value there, right? It does not touch. Now 4, it says determine the equation of the line of symmetry, right? So with this one, I said that they can either ask you to calculate the equation of the line of symmetry with a positive gradient or the one with the negative gradient. It's simple to do this one. You just simply take this, right? So if they say the one with the positive gradient, you simply just take that and you say y is equals to x minus 5 minus 2. Then you continue solving this one. Y is equals to x, -5 minus 2, that's -7. So you have the one with the positive gradient. As you can see, this is in the form of y is equals to mx plus c. So we can see our gradient here is 1, +1, right? So that's how you determine the line of symmetry with a positive gradient. But what about the one with the negative gradient? The one with the negative gradient, now you have to do like this. So now you have that like this, but then you need to put this one inside the bracket and have a negative here. Remember, negative gradient. So now for that equation, you have y equal to negative x minus 5 and then minus 2. So always note, when you want to determine the one with the negative gradient, you take the denominator, put it inside the bracket, and have a negative outside of that bracket. So now we have y is equals to negative x plus 5. Remember, negative and a negative is a positive, then minus 2. So the equation of the axis of symmetry with a negative gradient will be y is equals to negative x plus 3. So 5 minus 2 is 3. So that's it. So the one with the negative gradient and the one with the positive gradient. For the one with the positive gradient, it's simple. You just take this as it is. You don't change anything. You don't put any negative. But for the one with negative gradient, you put this denominator inside the bracket and then have a negative outside of the bracket. Then obviously you have to multiply in by that -1. So you can see this one is a negative gradient because the gradient here will now be -1, right? So you can see the gradient there is now -1. Now let's look at the last question from our 5 key questions. This is the one that will say sketch the graphs clearly, or sketch the graph clearly indicating all intercepts with the axis and the asymptotes, right? So now this is where you'll be putting all of this into the graph, right? So remember, you have your asymptote. Your vertical asymptote is x is equals to 5 from here, and then your horizontal asymptote is y is equals to -2. So remember, you need to clearly show the asymptotes, right? So this is how you show those asymptotes. So here we have x is equal to 5, and then where do we have the other one? We have y is equals to -2. In that way, we have shown the intercept. Then we have shown the asymptotes. Now let's show the intercept. Remember, when we calculated the x-intercept, we had 13 over 2, which I said is something like 6.5. So you can see with the graph there, that's 6.5, right? So you will have 13 over 2 is to 0, right? So you can even write it as 6.5 is to 0. There's no problem with that. And then also here you have this one, which we calculated it to be, what did we find for that one? So we had negative 13 over 5, which I said it's something like 2 point something, right? As we can see where it is, negative 2 point something. So that's negative. So that's, remember, that's your y-intercept. So it needs to say 0 is to negative 13 over 5, right? Negative 13 over 5. So that's how you have your solutions like that. So you have clearly indicated all the intercepts and you have clearly indicated the asymptotes. So done with that, usually this one will be about maybe 4 marks or 5 marks, right? There.